Hi, welcome to your Igneous Rocks enrichment activity for the week of April 27th. We are going to make some igneous rock cookies, and we're going to do that with any type of snacky ingredients we have around the house. I'm going to use chocolate chips, marshmallows, and cereal, and some peanut butter. And any variety of that will work just fine. If you have M&Ms instead, that'll work fine. Just try to get different hardnesses of different materials, like the peanut butter and the marshmallows are softer than the chocolate chips and the cereal, so that they won't all melt at the same time. So in order to make these igneous rocks, we're going to actually start with a different rock type. We're going to start with a sedimentary rock. And we're going to try to simulate that sedimentary rock being subducted at a convergent plate boundary. It's going to be subducted down into the mantle, where it gets completely melted and jumbled and mixed up, and then surfaces again through a volcano or just through hardening inside the earth to make an igneous rock. Because any type of rock that gets down into the mantle and gets melted into its basic elements again can come back as an igneous rock. So we are going to start with more of a sedimentary type rock. We're going to make some layers. Any type of container will be fine. If you will be putting it in the microwave, so nothing metal, and then you'll be putting it in the freezer a little bit. But it should be fine because we're not going to put a lid on it. So glass or plastic, mine's clear so that you can see what's going on, but yours doesn't have to be clear. Whatever you have will work fine. So I'm going to start with a little layer of cereal. Any cereal you have is fine. If you have Cheerios or Fruity Pebbles or Rice Krispies, it'll work out well. I'm just going to kind of put a little layer of cereal down here to make my first layer of my sedimentary rock. Then I'm going to add some chocolate chips and put those chocolate chips in to make my second layer. This kind of simulates the different types of sediments being deposited in a sedimentary rock. Then I'll add my marshmallows. It really doesn't matter what order you do these things in. I'm just doing it in this because it's what I'm doing. Okay, we've got some marshmallows. And then last but not least, we've got our peanut butter. And I'm just going to plop some peanut butter chunks in there. That's all. And then I'll smush it down a little bit. So as those sediments get compacted, it's going to form a sedimentary rock. So it's going to go under pressure. I'm going to kind of mash it down a little bit. So we've got some layers. And then as it gets subducted deeper toward the mantle, it's going to start melting. So I'm going to stick it in the microwave. I'm going to stick this in for about 30 seconds. Make sure you are watching this because marshmallows get really big when they're in the microwave, so you might want help from a parent or somebody else to watch it and have your finger on that cancel button just in case you need to cancel it right away. So I'm going to put 30 seconds on my microwave and start it. I'm pretty sure mine will be okay. This is when you get to lick your spoon if you want to. And then wait for it to be done. It's kind of fun to watch the marshmallows too. So this talks about the rocks as they get subducted under, they get heated, they get under pressure as they're moving toward the mantle. And just like we learned in chemistry, different elements have different melting points. It's the same with rocks and crystals and minerals. They all melt at different points. So the fact that not everything is melted yet is totally natural. That's how it works in real life too. So we've got our rocks They're going to get down into the mantle. They're going to get jumbled. They're going to get melted. They're going to get mixed up and tossed around and recycled. And then they are going to start eventually rising back toward the surface. And they can either cool, they'll cool eventually. They can either cool on the surface. If they come out through a volcano, they'll cool quickly on the surface, or they'll cool slowly inside the Earth's crust as they slowly move up toward the surface of the Earth again. So to simulate that cooling process, we're going to stick it in the freezer for about 15 to 20 minutes and let those minerals or let those different things harden. So it just so happens that I made one already earlier, so you can see what it looks like after it solidifies. So we have a nice igneous rock right here. I made this with the same ingredients, so it should look the same. And you can tell it's igneous because it has different types of minerals in it. You can see there's the white and there's the brown and there's the lighter brown and the tan, and it looks a little bit mixed up and swirled. But it also has different crystal sizes. And we learned in our readings that the different crystal sizes are caused by how quickly the rock cools once it reaches the Earth's surface or once it gets closer to the surface. If it cools slowly, it's going to have bigger crystals in it. If it cools quickly, it'll be smaller crystals. And then once you can pull it out and it's a hardened igneous rock, you can eat it because it's made with yummy things. I hope you enjoyed this activity, and I'll see you guys next week. Okay, bye.